This is Accelerated Geometry, Section 4.2, Properties of Isosceles Triangles. So the two pictures that I have here are buildings that contain many isosceles triangles. On the left here is the famous Trans-America building in San Francisco, and on the right is the Rock and Roll Hall of Fame and Museum. So both of those structures have many isosceles triangles in them. The next thing I want to look at is just the vocabulary here that deals with an isosceles triangle. So at the very top, I have what's called the vertex angle here. That is made by the two equal sides of an isosceles triangle. So an isosceles triangle is a triangle with two equal sides. Where those two equal sides come together is called the vertex angle. The two equal sides are called legs. The third side that is not one of the legs is called the base. And at each endpoint of the base, there are base angles. So that is the vocabulary that you need to know when you are discussing isosceles triangles. Next, there are two investigations that you should do. These are the ones we would do if we were in class. They are on page 210 and 211, and they will lead you to two conjectures, 18 and 19. Now, I am going to do those investigations, but I'm going to use Sketchpad instead of the way that they tell you to do them in the book. So the first thing we're going to do, we're going to say what happens if we start with an isosceles triangle. So if I have this, I want to get a side that is equal to that. So what I'm going to do is I'm going to highlight the endpoints and the segment. I'm going to double click on that one. It's going to be my place where it's going to rotate. I'm going to go transform, rotate, and I'm going to rotate that by, let's say, 30 degrees. Then I will finish up the triangle by going across here. And now I will name the vertex points. So there they are. Now I don't like this E prime. I wonder if I can change it. So if I double click on it, I can make that into the letter C. So there's my triangle ABC, and I think it is isosceles. So if I measure the distance from A to B, that's 6.5 centimeters. If I measure the distance from A to C, that should also be 6.5 centimeters, and it is. So I have an isosceles triangle. Now the question is, if you have an isosceles triangle, what is true about the base angles? So I'm going to measure the base angles. So angle ABC, I'm going to measure that angle. It is 75 degrees. And I'm going to measure angle ACB. And that measurement is also 75 degrees. Now, I made this angle up here 30 degrees, so I can't change that, but I can move it so that the sides become different lengths. So see how the sides are becoming different lengths, and yet the base angles remain the same. So if I have an isosceles triangle, then the base angles are equal. Now, I wonder if the converse is true. So I'm just going to do any triangle here. And I'm going to label it. So this is C, D, and E. Okay, I am going to also measure the distance from C to D. And that distance is 5.5. I'm going to measure the distance from C to E. I do not think that it's the same. Nope, it's going to be 8. And now what I'm going to do is I'm going to measure these angles. So this one is 79.4. And I'm going to measure this one over here. Now, I'm going to try to get this triangle to look like an isosceles triangle. So this part says, if I have an isosceles triangle, then the base angles are equal. Now I want to concentrate on what happens if I get these base angles equal. Will I have an isosceles triangle? So let's see if I can do something here. So there, I'll make that. Can I get anything nicer? Okay, 67.5. Let's see if I can get this guy to be 67.5. 67.4. 67 point, there's 67. What if I go back and make this guy? So I'm trying to make these be equal to each other. There's 72.1. There we go. 71.8 and 71.8. So I made the base angles finally be equal to each other, and look what happened. Up here, it is an isosceles triangle. Okay, so now, this would be the converse of this conjecture. So this conjecture said, if I have an isosceles triangle with two equal sides, then the base angles are equal. And this one said, if I create equal base angles, then the sides will be equal and the triangle is isosceles. Now there's one more conjecture in this lesson, and it has to do with an equilateral triangle. So I'm going to see if I can construct an equilateral triangle. So there's a segment. I'm going to kind of use a compass. So I'm going to go like that. Then I'm going to start here with a circle and go over there. So it's kind of like using a compass. I stab in at this point and make an arc above, stab in with the same opening and make the arc over there. And now I'm going to connect from that point to this end point, and from that intersection point down to that point. Okay, now I'm going to take away these construction lines that help me create that. So I'm going to go over here, display, hide the circles. So I think this is an equilateral triangle. Okay, now, if I measure the sides, maybe I should call them letters first of all. So here's F, G, and H. Okay, I'm going to measure this side FG, and the distance between those 2 points is 7.2. And from G to H, the measure of that distance is 7.2, so that's good. From F to H, the measure of that distance is also 7.2. So all three sides are equal, and now I'm going to measure the angles. So if I go F, G, H, the measure of that angle is 60 degrees. If I measure G, H, F, the measure of that angle is 60 degrees. And G, F, H, if I measure that one, the measure of that angle is also 60 degrees. So every equilateral triangle that has all three sides equal has three equal angles. So every equilateral triangle is also equiangular. And if I move this around, see how all the sides are changing? So the sides, they're all changing, okay? But the angles always remain the same. They're always 60 degrees. So now, let's go to the presentation again. And from this, we should be able to complete three conjectures. The first one says, if a triangle is isosceles, then its base angles are congruent. So here is my drawing of this. Two sides are equal. That tells me that the two base angles are equal. Conjecture number 19 says, if a triangle has two congruent angles, then it is an isosceles triangle. So these should be added onto your conjecture list with the sketches that go along with them. And then we did that last one. The last one said every equilateral triangle is equiangular, and conversely, every equiangular triangle is equilateral. And that would be a sketch for that conjecture number 20. So this is the end of today's lesson. And at the end of the lesson, you should now be sure that you have these conjectures on your conjecture list, and then you are ready to start the homework for this lesson.